Hello everyone, welcome to our pre-calculus class 9 from 4.3. This one is related to graphing rational functions. So let's begin. Let's say this question is given x squared minus x minus 6 divided by x cubed minus 3x squared, and we have to graph this function. There is some simplification possible. As you can see, this is x squared minus x minus 6, so we can do some middle term factoring here, and from this we can take x squared common, then we have this. Then there is some same thing in the up and down, so we can cancel them out and to get this. Always remember, if we cancel something which is related to the variable, we have to give some condition. As we cancelled out x minus 3, so x equal to plus 3, we cannot put 3 positive 3 here, because if for the positive 3 this becomes undefined. Just you have to keep it in mind, because there will be a hole for this in our graph. Anyway, so first of all, let's find out the domain. As you know, domain we find from the denominator of the given function. And see, this is x cubed minus 3x squared. So if we factor it, we get x squared minus x minus 3. So one undefined value is 0 and another undefined value is x equal to plus 3. For x equal to plus 3, this function is undefined. For x equal to 0, this function is undefined. That's why our domain will be all real number other than x equal to 0 and x equal to plus 3. We cancel out these things. Then x-intercepts. So how we get the x-intercept? To get the x-intercept, we always put y equal to 0. Y means this, fx here. So if we put y equal to 0, 0 here, then see 0 into x square means 0. Then x equal to minus 2 will come from here. This is how we get the x-intercept. Then to get the y-intercept, we put x equal to 0. So see, if we put x equal to 0, what happens here is our function becomes undefined. That means in this question there is no y-intercept. Vertical asymptote comes from the denominator of the function from the simplified version. For the simplification, after the simplification, whatever is remaining from there, we will get the vertical asymptote. This is x squared, so vertical asymptote will be x equal to 0, because there is no other things. Like if it is, let's say if it is x minus 2, then we have some other things to do, but there is nothing here, only x. So it is just x equal to 0. In other words, for x equal to 0, this function is undefined. That's why vertical asymptote is x equal to 0. So we have got couple of things, and then we can find out the horizontal or oblique asymptote what we have here. And as you can see, our maximum power is in the downside, which is x squared, and here this is only x. That means this falls in our condition number 1, which is if power is more in the downside, then we have our horizontal asymptote at x-axis or y equal to 0. So that will be our horizontal asymptote. This is our horizontal asymptote. And we have got one x-intercept at minus 2 from our previous slide calculation. Then let's discuss this. Look, now see, the reason why we need, this is a point in the graph, okay, and this is our asymptote, horizontal asymptote, and this is our vertical asymptote. This graph is, this point here is telling us there will be some other points around this point. This point is giving us some indication there is some other points near to this point. So we have to test some other point, put some value to get some, like, where is the other values, where is the other points. For example, this is minus 1. So for minus 1, we can put minus 1 here in the question. For minus 1, what is the value? Let's say for minus 3, what is the value of the function? So if we put some additional points here, it is for minus 3. For minus 3, we get this point. Minus 3, we have to put in the question here. Okay, then you will get this value. Then for minus 1, we get this point from the calculation. See, if I put minus 1 and minus 1 here, minus 1 plus 2 means plus 1 divided by minus 1 whole square means minus 1 whole square means plus 1. That means 1 divided by 1. 1 divided by 1 means this. So we get it this way. This way we get some additional points, and you can see actually there is another point coming. You can see actually there is some smooth graph is coming here, and this line will not go over the vertical asymptote. As you know, our graph will never cross the vertical asymptote. Then we can see if there is any more points here in this side. Actually, we have some idea that there will be some points here in this side, because as you know, for this graph, already we know that for x equal to plus 3, our function is undefined. For x equal to plus 3 from the simplification, as you know, we cancel out x equal to minus 3 from the numerator and denominator, so there will be some hole there in this side. For x equal to minus 3 is here, so somewhere here there will be some hole, and from that idea we know that there will be some graph in this side also. So where the graph will be, we need to locate some points. So if we put minus 1 in the question, then we get this point we get. Then this is the hole for x equal to 3. If you put 3 here, then you get this point you get. And ultimately, so we have got all this information, and if we graph it, then our graph becomes this. Okay, graph will look like this. See if it is matching with everything. I'm just coming in a while. Okay, I'm back. So we have got this graph. Although you cannot see the asymptotes in this graph, but they are here actually. There is one asymptote here, there is another asymptote here, and there is a hole there in this in the graph. So this is how we finish the graph, and these are the basic foundation of this whole thing. How did we do all these things, or why we did all these things? This is the steps for graphing the polynomial functions, rational functions. And see, the rational function is this form, and we have found y-intercept from the numerator. We have found it because if you put x-intercept from here, x-intercept from this numerator we have found. Because as you know, if we put 0 here, then this term into 0 equal to this term will be vanished. We will have just only this term. That's why we will get the x-intercept from here. And the domain and particle asymptote, as you know, we get it from the denominator. Then from this red box, this leading thing from the numerator and denominator, we will get the vertical and horizontal asymptotes. And these are all the steps we followed, other than near behavior, which we will discuss in the next slides. Next slides actually we will discuss it. Near behavior is similar to our finding the near behavior is similar to the things that we discussed. Oh my god, I'm sorry about this. Let me just do something there. Okay, I just cancelled it. Sorry about this. So near behavior is similar to our things that we discussed in our section 4.1. So just we have to put the x value and check it, what is the behavior of our function, what is coming there. Is it a straight line coming, is it a curve coming, what is coming there, and what is the slantness or inclination of the line. Is it uphill graph or downhill graph? We have this is coming up actually in the next slide, next class. And then we have another example here. And that one is we have to graph this function. So how can we graph this function? So see, there will be some oblique asymptote first of all. If you want to see oblique asymptote from here, because the power is maximum power is in the upside. Domain will come from the denominator, so all real number other than x equal to plus 2 plus 1, because x minus 1 is here, that's why. Intercept, to get the intercept we have to put x equal to 0 and y equal to 0. Then asymptote, as we said, the asymptote, vertical asymptote is x equal to 1, horizontal asymptote will be some oblique asymptote, we have to do the long division, etc, etc. Then we can locate some additional points to see the picture of the graph, and if you draw everything, then the put all the pieces together, then actually the graph will be like this. There is asymptote here, there will be some oblique asymptote here, and there is some vertical asymptote here. X equal to 1 is the vertical asymptote. This will be our final graph for this question. We have some practice also, like you will make some question, then you will graph it, kind of that graphing rational function free practice, like something you make and then graph it here. Alright, I think that's all for this class, and we have in the next class we have actually more detailed version of all these things, because actually what is happening with the graphic rational function is it is kind of little bit long process actually. In the class 10 we have the all of the things in detail, it will come here, many things will come here, and actually we'll go through more detail here about this. So we'll discuss it in another video. All right, thank you all, thank you very much, bye bye.